Hello, and welcome to today's Radiation Safety and Wellness webinar, Bridging Frameworks, the International System of Radiological Protection and the Hierarchy of Controls, with our guest, Kelly Fernandes of Workplace Safety and Prevention Services. Before starting, we would like to acknowledge that the spaces in which we at the Institute work in Toronto are located on the traditional territories of many nations, including the Mississaugas of the Credit, the Anishinaabe, the Chippewa, the Haudenosaunee, and the Wendat peoples. Fergal Nolan National Laboratories in Saskatoon is located in Treaty C6 territory and the homeland of the Métis people. We thank them for their care of the land and pay respect to them and their ancestors. We ask that during the presentation portion that the audio and video be from the presenters only. To turn on the closed captioning, go to More, Language and Speech, turn on Live Captions. Please use the chat feature for any discussions and post questions arriving from the content in the Q&A. This will help us find your questions for the allocated Q&A portion while allowing people to have a conversation in the chat. As the webinar is only 40 minutes in length and is immediately followed by the wellness session, time may not permit for us to answer all of them during the webinar. The answers will be posted on our website, along with a link to the video recording and a copy of the slides. This can be found under Education Webinars. I will be sending a confirmation of attendance email after the webinar and will include a link to the page with that communication. That will probably be towards the end of next week. I will also include the topics covered and the length of time spent in the webinar, as some people have requested this to send to the Professional Association. Today, I'm going to introduce the concept of Schema, and then Kelly and I will introduce and compare two frameworks that can be used to address health and safety in the workplace: the International System of Radiological Protection and the Hierarchy of Controls. Part of what we do at the Radiation Safety Institute of Canada is provide certificate courses to safety officers for workplaces that use ionizing radiation for both nuclear and X-ray. We often have registrants who have occupational health and safety or industrial hygiene background express concern that they may struggle because of the physics. They end up doing fine. There's a vast amount of information available on human cognition and learning. Understanding continues to be developed. In mental models and interdisciplinary synthesis of theories and methods, Jones and others summarize cognitive science and psychology literature with respect to human cognition. They explain that the concept of schema has a few different descriptions, reformatted here. The overarching concept is that as we learn, we build long-term knowledge structures that we then use to make decisions. These knowledge structures impact how we filter and organize new information. Applying this concept of schema, I can see that the pathways for people to the position of radiation safety officer or X-ray safety officer impact how they view their possible success in training and in the role. If they've worked around nuclear sources and X-rays, people will have experience and knowledge of the International System of Radiological Protection. If they've worked with traditional occupational health and safety or industrial hygiene, they will have experience and knowledge of the hierarchy of controls. But they may not have ever heard those systems named. The foundational frameworks are so commonly used that they are not necessarily explicitly mentioned, probably because it is assumed everyone knows about them or the original structure has been forgotten, and the concepts are just passed along. But with so many pathways for people to the realm of environment, health and safety, individuals may not have formally come across one or the other. Today, Kelly and I are going to have a combined presentation and conversation about these two safety frameworks and the broader concepts of radiation protection and traditional health and safety. We hope to improve communication between people with different safety backgrounds, to point out areas where misconception may happen, and to show how that even with no physics background, someone grounded in traditional health and safety can use their knowledge to move into ionizing radiation protection for certain applications. The ICRP is an independent organization that releases publications to support radiation protection around the world. It refers to these fundamental principles and safety principles within Publication 103, from which regulators such as the Canadian Nuclear Safety Commission and many radiation protection professionals draw guidance. The name of the document is the 2007 Recommendations of the International Commission of Radiological Protection. But recommendations for what? It's for a system of radiological protection. ICRP 103 sets out 3 principles of radiological protection. The principle of justification states, any decision that alters the radiation exposure situation should do more good than harm. The principle of limitation, the total dose to any individual from regulated sources in planned exposure situations other than medical exposure of patients should not exceed the appropriate limits specified by the Commission. And optimization, the likelihood of incurring exposure, the number of people exposed, and the magnitude of their individual doses should all be kept as low as reasonably achievable, taking into account economic and societal factors. The principle of optimization is often referred to as the ALARA principle. While studies show that at high doses, radiation-related risks appear to be linear for most health effects, it is not known what the dose response for human tissues and organs are for low doses of ionizing radiation. It is unethical to ask people to participate in studies that might increase the risk of cancer or other low-dose effects. The system of radiological protection is based on the linear non-threshold or LNT model, shown as line A in the figure. LNT assumes that the demonstrated linear risk from high doses can be extrapolated back to 0. As a conservative policy model, it assumes that there's no threshold for risk. A small dose will increase the risk by a small amount. Note there are other models out there. The optimization principle responds to the lack of the threshold through the requirement to keep doses as low as reasonably achievable. The phrase, taking into account economic and societal factors, is applied with the understanding that we live on a naturally radioactive planet which is continuously exposed to cosmic radiation. This clause involves weighing the risks of ionizing radiation exposure against those of everyday and occupational activities, while considering the overall societal benefits and economic implications of safe use. As I'm nowhere near an expert, I'm now going to turn to Kelly Fernandes to explain the hierarchy of controls. Kelly is a certified industrial hygienist and occupational hygienist at Workplace Safety and Prevention Services, with 20 years of experience in occupational health and safety. Workplace Safety and Prevention Services, a not-for-profit, is one of Ontario's 4 health and safety associations. They are dedicated to protecting workers and businesses by providing guidance, training, and resources to help organizations create healthier and safer workplaces. Kelly is recognized for her expertise in hazard identification, designated substances, occupational exposure monitoring, and implementing the hierarchy of controls to protect workers from occupational exposures. Her practical, evidence-based approach and deep understanding of regulatory requirements make her a trusted resource for both industry professionals and academic audiences, and our audience here today. Kelly holds a Bachelor of Science in Honors Biology, a Master's of Science in Environmental Plant Physiology, despite joking that she doesn't have a green thumb, and a post-diploma in Environmental Engineering. She is passionate about promoting safer workplaces and sharing her knowledge. We are very glad that she's agreed to join us for today's webinar. Welcome, Kelly. And with that, I'm going to turn things over to you to discuss.
Perfect. Thank you so much. That was a wonderful introduction. So I'm here to talk about the hierarchy of controls, which essentially is part of my day-to-day life when I am working with employers and workers. As you can see from the diagram here, at the top is elimination, and at the bottom is PPE, or personal protective equipment. And you'll also see that as you move down that hierarchy of control, hence the reason why the triangle gets smaller and smaller, you see that it is least effective. So why is this? I'm sure you can imagine that if I eliminate a hazard, that is going to be more protective than providing PPE to a worker. And the reason for that, why PPE is at the bottom, is that we're human, right? We may forget to wear our PPE. You know, I've walked in I've put my safety glasses on the top of my head while I went into the office, and I walk into the plant, and then a worker's like, and I'm like, yep, put them down, right? Or we may not put on our PPE properly. For example, we may have hearing protection that we don't use the proper technique to put our earplug in. And so it's actually not fitted properly and we're not protecting ourselves, or it may fail. So what does that look like when I am implementing the hierarchy of controls in a workplace? When I start with elimination, I discuss with the employer, is it practical to eliminate that hazard? So if we're looking at noise or a chemical exposure, can we stop using the product, or can we stop using the press in the facility? Most likely not, right? In many of these situations, the workers need to use the equipment or that particular product. So then we move down to the next step, which is substitution. Okay, so we have like a glue, for example, that we need to use that has some chemicals in it that are potentially harmful to the worker. Can we substitute it? Can we change it for another glue that maybe doesn't have the same volatile organic compounds in it or chemicals in it that is as dangerous? And then if we can't do that, then we rely on engineering controls. This is kind of really where I hang out when it comes to the hierarchy of controls, because a lot of times there may not be a substitution, and of course we cannot eliminate the work entirely or the hazard entirely. So we're looking at ways that we can prevent the either the noise or the chemical getting to the worker. So that could look like having local exhaust ventilation over the process. Or if you've been in a facility, maybe they are spraying glue, they may be doing it in a booth where it is taking the vapor and aerosol away from the worker before it even gets to their breathing zone. And then the next step, or engineering controls, for example, looking at maybe we do have that press that is like banging and making a lot of noise. Can we put up barriers that stop the noise from getting to the worker before we even need to rely on other controls like hearing protection? Administrative controls is an important part of any health and safety program because it includes looking at ways that you can reduce exposures or even educate the workforce. So training is a huge part of health and safety and is needed regardless. Workers need to be aware of the potential harm that can come to them and how to protect themselves. And administrative controls could also be rotating out workers. It could be, so for example, if I'm going to be exposed to noise for 8 hours and I am going to be over the exposure limit to which I'm allowed to be exposed to, maybe we can rotate me in for a few hours at a time. So I'm actually decreasing my exposure. It also includes your policies and procedures, which I'm sure everyone here is aware of, because I know you need them for radiation safety as well. That's a crucial piece, even though it's lower on the hierarchy of control, because having a policy or a procedure, right, it's great to have, but if people are not following that procedure, then it's not as protective, again, as if we just got rid of it entirely. And then at the bottom, we have our PPE, such as respirator, gloves, safety glasses, and hearing protection. And the hierarchy of controls is a practice that hygienists use, but it's not just a practice that hygienists use, it's built into in Ontario into our health and safety regulations. So just like Lynn was speaking to, it may not explicitly say like these are the hierarchy of controls, but in Ontario, when it comes to exposure to a chemical agent or noise, there's actually a requirement that workplaces go through the hierarchy of controls and implement those before relying on PPE. So many times we may go into a facility and they have noise or they have a chemical exposure and they immediately give out hearing protection or respirators to protect the workers. And that's great for that moment, because obviously we want to protect our workers and ensure that they're not being exposed. But if they haven't even gone through the hierarchy of controls to determine if there are more protective controls that can be implemented before relying on PPE, then that's actually a contravention of the regulations. And you may go through this process of engineering, of going through the hierarchy of controls. For example, implementing an engineering control. I've been in facilities where they have engineering controls, but they still have to rely on PPE. It's just that they don't have to rely on higher levels of PPE, if that makes sense. So for example, respirators have different protection factors to them. So instead of having a worker, let's say like they need to be in supplied air because it's just the exposure level is just like immediately dangerous, like it's very high. But if they have that engineering control, it brings the exposures down, not below regulated exposure limits, but it still brings them lower that they don't have to be in a full apparatus. They could maybe be in a half-face respirator. Then that's a requirement as part of the regulations. And so I always tell my clients it's really important to document that you've been through this process. It can be a simple paper exercise, it could be a checklist, an Excel sheet of going through, okay, we have this product and workers are being exposed to benzene. Can we eliminate it? No, we need it. All right, can we substitute it? We tried to substitute this glue and it just gummed up our processes. It didn't work, unfortunately. All right, next. So we can't substitute, we still have to use it. Let's do an engineering control. Okay, we put an LEV over the work, or the work is being done in a paint booth, whatever that looks like. And we brought our exposures down. So, you could stop there, but let's say you couldn't stop there and you need to keep going, then you would look at your policies and procedures and ensure that workers are trained, and maybe instituting that rotating to decrease their exposures. And then finally, if we've done all of this and we're still above exposure limits, or even at 50% of exposure limits, then we want to rely on, not rely on PPE, but add another layer. I think we've probably all seen the Swiss cheese model, where you try different things, and then eventually you get there where you're as low as you reasonably can be. And that's really where we want to be. So Lynn was also talking about ALARA. That is also in some of our regulations as well. For like, as a hygienist, obviously, I am always going to want to push for as low as reasonably possible, as much as I can. But for some of our chemicals, our designated substances, that's actually also written in the regulation that we need to get it as low as reasonable that you can for doing this work. And that is the overview of hierarchy of controls.
Thanks so much, Kelly. It's really appreciated. So now what we're going to do is I'm going to go through an example of where you might run into the hierarchy controls in radiation protection. And, that it's not explicitly explained that this is a very fulsome system. And going back to that, sometimes it's helpful to at least give the reference, so somebody not familiar would be able to go and learn more about it. So this example that I'm going to use of where the hierarchy controls is found in radiation protection regulatory expectations, without it being explicitly stated as to where to find more about it, is in the Canadian Nuclear Safety Commission's Reg Doc 2.7.1, radiation protection. To quote the CNSC, regulatory documents generally present both requirements and guidance in a single document. So it's not the regulations, but they embed the regulations and guidance as to what licensees are supposed to do in one document. And they have a series of these documents. In Section 4 of this Reg Doc is on ALARA, and it also uses the language of hierarchy controls. Section 4.4 reads in part, the preferred method of exposure control is through the elimination or reduction of the hazard. If elimination or significant reduction is not possible, the primary means of controlling occupational and public exposure to radiation is typically through engineered controls. When the use of the physical design features, including specific engineered controls to limit radiation exposures, is impractical or inadequate, the implementation of administrative controls may need to be considered to ensure that protection is optimized. It continues further down. Control measures such as quality and design, maintenance and operation, together with administrative arrangements and operating procedures instruction, should be used to maximize extent possible before relying on PPE for ensuring the protection of workers. In circumstances in which engineered and administrative controls are not sufficient to provide adequate levels of worker protection, PPE should be provided to minimize the exposures of workers. The document also refers to following the hierarchy of control, all lowercase, in a few places, but it gives no reference document. For someone who knows the hierarchy of controls, this is familiar language and a familiar structure. For those who are new to the field of health and safety, the terms elimination, engineering controls, and administrative controls may be unfamiliar and the methods of implementation for each not fully understood. They may not have an appreciation for the hierarchy as a formal concept. It is like the meme of the fish not seeing the water in which they swim. As the radiation protection industry is expecting to face staffing challenges due to retirements and an increased demands for nuclear technologies, it is important that those who are experienced support those who are moving into the industry by giving reference to foundational concepts that have become second nature to them with time. Many people can get the concepts, but they have to know that they're there to be learned. So going back to the concept of schema, are scaffolds for new knowledge, that these, by reflecting on those and sharing them, it's going to help us to partner with others more effectively and find areas where misconceptions may arise. Because there's little differences, as you can see, between the radiation protection system and the hierarchy of controls, because they were developed over history, over the time, for slightly different purposes. So with this, I've put together just my thoughts. This is not research. It's not a study that was done, but just reflecting on these two systems. Here are some of the overlaps between the system of radiological protection and the hierarchies of controls. And I invite Kelly to add her thoughts as I'm going through as a conversation back and forth, just how I would interpret it as somebody in RP versus somebody that has the industrial hygiene background. So with looking at an elimination, that if we are using a nuclear source or an X-ray source, the risk is going to be there. For some applications, there's no alternatives. And if an alternative is found, the system of radiological protection doesn't even apply, right? So you'd no longer be using it in the workplace. You wouldn't need to get a license, or you wouldn't need to deal with X-rays. Some provinces require registration and things like that. If you eliminate the ionizing radiation, then you don't have to worry about the system of radiological protection. Kelly, I don't know if you'd explained elimination really well, but
yeah, it's the same. So it's very similar, right? Whereas when we're looking at elimination, if we eliminate the source, then there is no other. That's why it's at the top. There's no other need to go through the other controls. But a lot of times, unfortunately, that's not practical in our manufacturing or medical facilities.
And how I was thinking about it in terms of how this is a little bit different in terms, you might get rid of the radiation, but there may be other hazards there, right? Whereas in a traditional workplace that has hazards but no radiation there, you might eliminate the hazard for one thing, but there's still a number of other hazards around. Right.
And that's why it's important not to just look at the one item that you're looking at without pulling in the information. So in Ontario, we have, the internal responsibility system where we work, it's not just a top-down system of like management to workers. We want workers' input. So,
Yes.
Going back to like one of my examples of noise, of putting up a barrier or even surrounding it so the noise doesn't get to the worker. But if that's going to cause a fire hazard because the heat is going to is going to build
Yes.
up, right? We can't, yes, the hierarchy of controls, it's really important for us to look through, but again, not in isolation. We need to be pulling in more information to ensure that the controls we are putting in are going to be protective and practical.
Yes, and from the chat room, and again, if people have examples or things they wish to share, this is a more conversational webinar than in the past, but an example of elimination is no longer using smoke detectors with radioactive isotopes such as americium-241. There are alternative technologies to adequately detect smoke from fires. So thanks for that example. In terms of substitution, there are examples of substitution instead of using ionizing radiation. Ultrasounds instead of X-ray equipment for pregnant women, for example. And in industry, that there are technologies such as radar ultrasound density gauges when they can be fit inside the vessel. But then sometimes there's concern with humidity and things like that, that they may not be as reliable. And the nice, we don't promote using nuclear or not, but a lot of times where the nuclear density gauges are used, you don't have to run electricity to them. So if you're using things that do have electricity, that the electrical hazards that come along with creating X-rays, for example, instead of nuclear, that introduces another hazard, right? So again, it's not always possible. And I think you gave good examples when you were going through that, sometimes you try something else and it just gums up the works or doesn't work at all.
Yeah, and also thinking future, right? Being future focused, that I may have, that example that I gave with the press, I may have a press that is in operation right now creating a noise hazard. But as you mentioned, technology increases, right? We bought that press 20 years ago. We are looking to replace it in the future. Can we replace it with a press that doesn't create as much noise, or a different piece of equipment that makes the same product but is not as noisy?
Yeah, and that would be similar with X-ray systems, that a lot of them, the older ones, that there are more modes that would be hazardous than the newer ones. But I guess in a way, those are engineering controls, putting better collimators on, things like that. Yeah. Okay, so some engineering controls. These are frequently used in radiation protection. Out of these quotes are from that Reg Doc 271. It says properly designed workplace as well as appropriate personnel safety, radiation monitoring, emergency response equipment are examples of engineering controls. Shielding, the use of shielding is like built into bunkers and built into X-ray rooms and into the equipment themselves. So they're quite commonly used. I just need to, sorry, the way Teams works, people disappear when I change the slide. And then, yeah, and then in terms of administrative controls, these are frequently used, just as you had said, education training is a big portion of what regulators are looking for. Having your procedures and policies not only in a binder that sits on the shelf, but evidence that you're actually implementing them. So looking at proper paperwork and record keeping to document that the activities you say you're doing are actually being done. So what they'd say in 271 is work procedures such as written safety policies, work authorizations such as radiation work permits and restrictions, access controls to areas with potential radiological hazards, and training. And I think in speaking with you before the webinar, you had said that often when you're looking at things like training is broken out as its whole other thing
Level
with the hierarchy.
Yeah. Yeah, and another important piece, when it comes to administrative controls and our work procedures, is getting that feedback from the workers, because they're the ones that are using the equipment, using the materials. They're in it every day, and they may be able to, from like start to finish of what their day looks like, give you information on how to make those procedures even better, or even make the workplace safer.
Yeah. I note in the chat that someone is pointing out that it's important to note that substitution is replacing a higher hazard with a lesser hazard. A risk still remains after substitution, but it must be lower. If substitution creates another hazard with equivalent risk level, but perhaps different risks, it's not substitution. And yes, that if you're still bringing in it's just wrapped up in different packaging. It's not the same. And I was trying to think ahead an example in terms of replacing, nuclear with X-ray. There's still ionizing radiation there, and if the electrical hazard is actually more concerning than the nuclear hazard, depending on what you're using, that you may not be getting a benefit there. And then for PPE, preference for higher level control actions, for example, air exchanges and preference to respirators. And again, from 271, consideration should be made to determine if the benefit afforded by the PPE is outweighed by the consequence of wearing the equipment. All radiological hazard types, as well as conventional hazards, should be considered when selecting PPE. And there's someone in the chat is saying using PPE would be considered mitigation in the hierarchy of controls. Hazards can also be mitigated by taking human actions like spending less time in the zone and staying. So in radiation protection for external, we have the time distance shielding. Yeah. So spending less time, that's part of the time aspect. So again, some of the very similar concepts are there, but they're wrapped up in different wording. So and again, with the hierarchy controls, noting we have people from a global audience here, that the one that's used in the US and Canada, that they have certain levels in the pyramid, the upside down pyramid. But I think internationally that they might have slightly different language around what the naming of the different levels in the hierarchy are. So it's interesting, the difference, and it's something to be aware of, again, if you do work internationally, that North America may do something different than Eurasia or other locations. So I don't know if you want to hop in to add anything else, Kelly.
I just kind of wanted to add occupational exposure limits and how there's a difference between compliance, right? So I'm above that limit, I'm below that limit, which is compliance or like legislative wise, and coming back to the concept of ALARA and how as hygienists we are looking at everything in between from at the exposure limit to below, and we're also doing analysis within each of those. So if I mentioned like if I'm at 50% of an occupational exposure limit, I may start to use statistical analysis to determine, because for the type of work that I do when I'm going into a facility, it is a snapshot. I can't put something on a worker like a pump and media in these facilities every day. I can't monitor every day. It's not practical, and I think workers would be really mad at me. But so I use other tools like statistical analysis to help me determine if on another day, so like using Bayesian statistical analysis programs to tell me if maybe on another day the worker would be overexposed, and using those kind of tools that I have to then say, okay, we are at 50% of the OEL, you're not over, but let's start implementing these hierarchy of controls. Let's start going through it now so that we don't get to a point where we are overexposing our workers. So it's not just like at like a compliance limit. We are looking to implement this even before.
Okay, great. And then just looking at some of the unique features of each, and just when I was initially looking at this, thoughts that I had, and again, I'll invite Kelly and people in the chat. In terms of what's unique, in terms of hierarchy controls, that it's really looking at worker protection. And the system-related radiological protection, if you get digging through it, it's also protection for people and the environment. And I know there's the broader category of environment, health and safety, so EHS as people, and environment in itself is a whole we didn't invite anybody in from environment, but I know, Kelly, you have a background in that. So I don't know if you have any comments as to what that adds to the picture.
Yeah, that's been a long time ago, but the environmental work that I did. So yeah, I don't.
And I assume they have their own systems of and structures
They
and
do,
frameworks.
and a lot of times the levels tend to be even a lot lower than exposure limits, just because it's the public that you need to
Yes.
protect, and the land and the water and the air. Yeah.
Yeah. And with the hierarchy controls, it could be applied to any hazard, whereas the system of radiological protection is specific to radiological protection. And as we're talking through this, I'm big on analogies. I'm thinking about the difference between a medical doctor and a veterinarian. A medical doctor deals with humans, and a veterinarian could see anything. And I think the radiation protection system is kind of like a medical doctor. It's focused on one, whereas the hierarchy controls, it's much, much more broad. With hierarchy controls, that a lot of the hazards are not dose related. If you fall down a flight of stairs, you fall down it's not how many times you fall down the flight of stairs. It's how you happen to land. Whereas the system of radiological protection, it happens. It focuses on doses a lot of the times and exposures. It's very much looking at the energy. And if it is with the hierarchy of controls, if it is dose related, it's often keeping it below a threshold limit value is appropriate. That there are limits that it's assumed that if you're in that amount every day, that there would be no health effects. And the system of radiologic protection is driven by the ALARA principle, but as Kelly has pointed out during the webinar, that is often in the background as well, even with threshold limit values, that we're still trying to keep it below there. So that's a learning I will take away, that even if there are threshold limit values, that's sometimes in legislation or sometimes in the expectation is that we're still trying to keep it lower than that. And the hierarchy controls can be a part of a broad occupational health and safety program with individual components such as training broken out by specific hazard. So you may have work groups that, you're learning about this hazard and somebody else learning about that, because depending on what they're being exposed to. And then with the system of radiological protection, there's requirements for training, internal reviews, record keeping. That's part of an overall radiation protection program. Again, it's a very singular focus. So I'm not sure if you have any other comments of things that you could see. I know you're not that familiar with the radiological protection system to ask.
Yeah, I live in mostly noise and chemical exposure.
Yeah.
Yeah.
But I think it's a very fine difference, and it comes from, again, the broad versus the narrow focus on each, and the historical. I think health and safety, the saying often goes that every piece of regulation is written in blood or because of an accident, right?
Yeah.
I think it depends on the experiences that the powers that be had with incidents that have happened, that have developed them over time.
Yeah, and CIHs are tested to
Yes.
radiological protection,
Yeah.
but a big part of our credential is experience, right? So you
Right.
need that experience before you can, so that maybe look like partnering with someone who has done that work or taking the RSO course,
Yes.
so that you gain that experience before you just start implementing or doing any of this type of work, right? I'm
Yeah.
sure other people have very similar ethical standards to their credentials as well.
Yeah. And you could see, I hope people can see that part of my reason for wanting to do this is so that people who may see this, who are in industrial hygiene or occupational health and safety background, you have a large foundation of knowledge there that will help you. Now, granted that for certain applications, if you haven't had the full course, like with industrial radiography, there's requirements from NRCan to have certain training on how to use it. If you're going to be a nuclear medicine tech, you need more than that. But if you're being the safety officer, don't shy away from the physics, right? You have a large foundation in the correct mindset towards health and safety to be a good safety officer. You just have to learn the physics. It's not that hard. So when we take a look, just looking at the time, some final thoughts. is that radioactive sources are found everywhere, including naturally occurring radioactive sources. Occupational health and safety and industrial hygiene have many great systems and processes to protect workers from a wide range of hazards. Radiation protection, occupational health and safety, industrial hygiene have these parallel overlapping systems. There's value in breaking down silos, looking for common language, and in effect, sharing our schema. We need to be explicit with our foundational thinking, not in a way that's condescending, but rather in a way that checks to see if we're thinking the same thing when we use language, and in a way that allows for sharing improved safety practices. So looking at the time, it's been a great conversation, Kelly, that we really appreciate you being here. I'm just going to flip through. We don't have the time. Our Q&A was kind of embedded. I had some interview questions, whatever, depending on timing. So we will take away the questions that were put in the chat room and in the Q&A. And what I do is I create a document with some answers. If Kelly's not available to help get answers, I'll dig them up and get an expert to take a look at it. But that'll be posted probably towards the end of next week because of the holiday next week. But just know that those will be posted online in a document, so they will be addressed. It's just we're at a time for the live portion right now. And then the video and a copy of the slides, a PDF copy of the slides will be included. So you'll have the reference links. So if you have questions about any radiation safety topic, please feel free to contact us at the Radiation Safety Institute of Canada. And Kelly, is your supports from WSPS are for residents of Ontario, Canada, correct?
Yeah, our focus is the workers of Ontario.
Yeah, but they do have a wonderful website with resources on it as well. So is that WSPS.ca?
WSPS.ca.
Yes. So you can also visit there and they have resources. We have a toll-free information service to support questions from employers, workers, and the public with respect to both ionizing and non-ionizing radiation safety. We also provide consulting services to those who might need support in developing a radiation protection program and related services, including radiation surveys. If you have any further questions about ionizing or non-ionizing radiation, please feel free to contact us toll-free at 1-800-263-5803 or by email at info@radiationsafety.ca. You can also visit us on the web at www.radiationsafety.ca. Find us on Facebook, LinkedIn, and YouTube. So, Kelly, thanks so much. The time went by really quickly.
It did. Thank you so much for having me. Maybe we could do this again and just do the Q&A.
Yes, yeah. Or bring another topic and we can have a chat about it. So thanks for that. And with that, I'd like to introduce Charmaine Wong for those that come often. You've seen Charmaine before, but for those who aren't familiar, that we now have a 20-minute wellness break in the form of beginner Tai Chi with Charmaine Wong of Jihong Tai Chi and Qigong in Richmond Hill, Ontario. So we're not just about radiation protection and worker protection, it's about whole body wellness. A lot of us sit every day and don't move around a lot, and a sedentary lifestyle is not necessarily a healthy one. So welcome, Charmaine. I'll stop sharing now and turn it over to you. We do realize that the webinar is intended to be over a lunch break. If you do need to go, we appreciate it, but if you can participate as you can, even if you can just do the stretches, it is beneficial to your overall health. Thank you.
Okay, so I'm gonna try to do the sharing now.
Yeah, that's looking good.
That's looking good. All right, so okay, all right. All right, so hi everyone. Sedentary lifestyle definitely is not good. So let's get off the chair and do some gentle movements, gentle exercises. Hopefully you'll get energized or re-energized after this session. All right, so now first of all, let's stand with our feet shoulder width apart. All right, now the very first movement is very simple. Let's just put our fingers together with the palms facing up. And then we're gonna bring the hands up to about chest height. Then we're gonna rotate our hands so that the hands are facing up towards the ceiling. And we're just gonna stretch up. Stretch up gently, not stiffening up. And then at the top of the, when you raise the hands to the top, then you open the hands, bring them down the sides. gently sit down a little bit, and then we're going to do that again. Now this time I'm going to prompt you for breathing. So it's the best place to breathe in is when you raise your arms, you slowly breathe in. And then as you release your fingers and bring the arms down, you slowly breathe out. Now the gentle squat, you don't have to go very low, just bend your knee joints, bend your hip joints as if you're trying to sit down onto a high chair. And let's do that again. Breathe in. Breathe out. The Qigong and Tai Chi are both done in a slow and gentle manner. There are studies that say that this manner of doing your exercises really cultivates your energy, which makes you feel more alive after doing this. You will feel that you seem to be more awake, hopefully. All right, so let's do that again. This is more just a warm-up exercise, all right? So breathe in. Breathe out. One last time. This is really an underrated movement because it's so simple. You can very likely remember this after this session. So do it every now and then during the day. You'll find that it would be really helpful. All right, so bring the hands down. Okay, then we can rest for a few seconds. Now we're going to do a second warm-up move, kind of similar to the previous one. We're going to reverse the direction of the circle. So now just raise the arms onto the sides first. All the way up. And then turn the palms back towards each other. And pull the elbows down. The main difference between this one and the previous one is that this one incorporates a little bit of a pulling action. It starts to make you think about your core. So imagine using your core. Pull down. Using your core, connect your core to your elbows to pull your arms down. It starts to go more into the realm of Tai Chi, using your core to direct your movements. Repeat. Bring the arms up. Keep the shoulders relaxed. Imagine using your core, pulling down. Just one last time. Pull, yet not stiffen up. All right. Okay, so that basically finishes our warm-up movements. Now we're going to go into two actual Tai Chi moves. The first one, we call it cloud hands or waving hands in the clouds. So it requires a certain stance, what we call a horse stance. So a horse stance is like as if you're riding on a horse. So it can also be looked at as a squat, but what you want to do is you imagine you're really sitting on a horse. The body's still upright, so don't lean forward. Try to stay upright, but with the hips bent, hip joints bent, as if you're sitting on a horse. Okay, so we can get back up, rest a little. Let's do that again. As if you are sitting on the saddle of a horse. And back up. Now this move really strengthens your lower body. Very helpful to develop leg strength. Go down. The toes are more or less pointing forward. Let's do that one more time. So you get used to the feeling of that sitting feeling. Make sure you're not just bending your knee joints. Now I'm going to turn sideways to let you look at how it should look like. You sit here. Okay, now I'm going to demonstrate a wrong method of doing this. If you are just bending your knees like that, you really cannot sit down. That's wrong because it's putting a lot of pressure on your knees. So just do it one more time in the right way. You want to sit and then come back up. Okay, now then let's go through what the hands should look like. Cloud hands, one hand is at the top, either hand. Let's say this is your left hand. The other hand is here. So the top hand with the palm facing yourself, the other hand with the palm facing down. You want to feel like you're wrapping around a ball. Now this time actually I brought a ball. I don't know if you can see it in the image, in the mirrors, this exercise ball that we have. You want to feel like your whole body is an inflated ball. You don't want to do it this way, right? That like feeling the inflation, feeling like that you are, the fullness of the body actually has a lot of good health benefits. So imagine you're holding around your arms a big ball, inflated ball like this. Now cloud hands would mean that you turn to one side. Let's say when you have the left hand on top, you turn to the left side. Then we switch the hands. The other hand goes up and your left hand goes down. And then you go back to your right side. Whichever side has the hand at the chest height, that's the side that you're going to move to. So let's say if you have your left hand up here, then you move towards the left side. Let's do that again. You just move the hands up and down, still holding an inflated big ball around your arms. And switch. We're going to add our footwork later on, but let's just go with our hands. Practice one more time. You want to be inflated, yet like that ball, you're not stiffened. You're not a bowling ball. You have elasticity on the outside. So the outside remains soft, yet inside you want to feel like you're inflated. That's one of the secrets of Tai Chi training. That's how you want to feel like in all of your movements. All right, so, okay, now we're going to add our footwork. Now, footwork for this one is pretty simple. After we do the horse stance, we're just going to step sideways like this and then back. All right, so now here, I'm going to start off with a little bit towards the left side. You can do that as well if you have the space. Let's slightly put the feet a little bit farther apart. And then we're going to have our hands ready. Now I'm going to go to this side. So that's why I have my right hand ready. All right. So now I'm going to step a little bit farther away. I'm going traveling that side and I'm going to move my weight as well as slightly turn my body. I'm going to switch to the other hand and put the foot close a little bit closer, but not all the way together. And I'm going to move my body back, the weight towards my left side. And then I'm going to do it again. Switch the hands and I'm going to step. Move towards my right side. Switch the hands. Bring the left foot a bit closer. Back to a narrower horse stance. Move towards the left side. Switch the hands again. Step. Switch the hands again. Step. And you keep shifting weight as you move from one foot to another. Now it may feel a little bit tiring if you're not used to this. This is how we strengthen our legs. Let's do it again. One last time towards this side. Okay, now back to the middle. I'm going to go back to that direction and that we can wrap this movement up and we can go to the next one. All right, so now go to your left again. Switch your hands. Step your right foot. If you need to rest a little, you can straighten up and then start again. For those who can hang in there, You can stay a little bit squatted throughout. We're just going to do it one last time towards the left. All right. Now we can take a rest. All right. So now the next move that we're going to do is called parting of the wild horse's mane. So the stance that is required in that move is called a bow stance. A bow stance looks like this. There is a front foot stepping towards the front with the toes facing forward. The back foot with the toes facing slightly out to about 45 degrees. Our weight is generally mostly on the front leg. Make sure the back foot's heel is still firmly on the ground. So the back leg absorbs about 30 to 40% of the weight. Okay, so side view, it looks like this. Almost like a lunge, not quite exactly like a lunge. We want to keep this back leg straight. Just don't lock the knee. Keep the knee a little bit flexible. And we're going to sit on one side, keeping the body mostly straight. Let's switch to the other leg for practice. The other leg, same thing. The front leg, the knee and the toes point forward. The back leg, the knees and the toes slightly point outward. Body squared towards the front. You can see from the buttons here that my body is squared to the front. And the weight distribution is that it's more on the front leg. This is the bow stance. Okay? Now, so let's practice the bow stance by stepping forward into a bow stance from the feet being shoulder width apart. Let's say I'm going to step my left foot first. So what I'm going to do is turn this foot. It will become the back foot, so I turn it out to about 45 degrees. I pick up the other leg and let it step forward. And then I move my weight towards the front to finish the bow step or bow stance. Okay, let's do it on the other leg. Now I'm going to step forward my right leg, so my left leg would become the back leg. So I turn it out to 45 degrees. Of course, you sit down a little bit, right? You bend all the joints, the knee joints and the hip joints. And then I step forward with my right heel going forward first. Then I shift my weight into finishing the bow stance. Okay, now just one more time and we'll add our hands, okay? So now one more time on each side. Turn out your, let's say, right toes. The other foot would be the one stepping forward. Think about stepping out a little bit wider towards the corner because you don't want the 2 feet to be on one line. If that is the case, then you will not feel balance. You want a little bit separation. All right, so try the other leg. So again, it requires a bit of leg strength, especially when you do this really slowly. All right. Okay, now we're gonna see how the hand movements look like. In terms of this parting wild horse's mane, there are 2 parts of it. The first part is what we call the whole ball. Like there are a lot of balls, the analogies, as Lynn was saying, we love analogies as well. So we use the ball to imagine something around our arms. Not a small ball, you want a big ball, and the ball is more 3-dimensional. So you put the arms a little bit more forward like this, okay? Now, as we turn to one side, let's say I'm turning to my right foot. My right foot would be the one standing. Then you have a right whole ball, being the right hand is on top. And then as I step to the front, the second part of the hand movements would be parting wild horse's mane. The lower hand goes up and forward. The upper hand just presses down like that. So I'm going to show you again. You can follow along. Let's say the right foot is turned out. When I move my weight to my right foot, I'm going to have a right whole ball, holding the ball with my right hand on top. Then I'm going to step forward with my left foot. Don't transfer weight yet until you're ready. Then you transfer weight and then the hands start moving. As you transfer weight, the hand at the bottom goes up to the upper corner and the hand on top just presses down in front of you. Okay? Now let's do that the same side one more time. It's easier that way. Your right side, turn out. Hold ball, right hold ball, meaning your right hand is on top. Both palms are facing more or less each other, okay? One faces down, one faces up. Step forward, heel down first. Then as you transfer weight, the hand at the bottom moves forward and up. The hand at the top pushes down. Okay, let's do the other side. It will be the same thing, just a mirror image. So turn out your left toes first. As you move your weight to the left foot, do a left hold ball. Your left hand is on top, right hand at the bottom, holding a big ball. Then the other foot, the other leg, right leg, step forward, heel down first. As you transfer weight, the hand at the bottom moves forward and up to the corner. The hand at the top just presses down. All right, let's do the same side again. Your left foot turns out. Move the weight to your left foot, left hold ball. Hold the ball on your left. Put the other leg forward. As you transfer weight into a bow stance, you separate the hands, parting wild horse's mane, as if you are really trying to feel the softness of the horse's mane. All right, so now again, the same side. Hold ball. Step. Move. Okay, let's do that one more time on each side. Actually, we can have time for 2 more times on each side and then the cool down move, and I think that we would run out of time by then. All right, so 2 more times on each side. Right side, right hold ball, left foot forward, and parting wild horse's mane with a bow step. All right, same side, one more time. Right side, right hold ball, left leg forward, transfer weight, parting wild horse's mane. Okay, and we'll finish on the other side. So left side, turn out toes, left hold ball, step forward, right leg, shift weight, parting wild horse's mane. One more time, last time. Left toes, left hold ball, big ball, inflated ball, step forward, transfer weight, parting wild horse's mane, still feeling the fullness in the body. Okay, all right. Now let's just do a quick cool down and we'll finish our session. All right, so now the cool down is easy as well. Just turn the palms up, bring the hands up to about waist or chest height, breathing in. Turn the palms back towards yourself and towards the floor, breathing out and put the hands down. Let's do that 2 more times, slowly. Breathe in. Breathe out. One last time. Breathe in. Breathe out. Okay, so that wraps up our session. I'll turn it back over to you, Lynn.
Thank you so much, Charmaine. We really appreciate you joining us. And thank you to everyone that was able to stay to the end. That we hope that we're able to see you next time. This is the last one we usually run a series of 6 each year. So it'll be again probably in the fall before we have another one, but who knows, there might be one over the summer. So enjoy, and everyone have a safe day. Thank you.